Hey guys, in this video I'm going to be walking us through a lab I've made in Cisco Packet Tracer. So the lab is going to be consisting of OSPF, DHCP, NAT translation, network address translation, and what am I missing? InterVLAN routing, yeah. So right now we have three layer 3 switches and it's going to be doing the VLAN routing, the VLAN. So the OSPF is going to be the dynamic routing protocol we're going to use to pass network traffic to be able to reach, the ISP or NAT router and also be able to reach all the VLANs wherever we want to go. So right now I've created the method procedure, and all I have to do right now is just copy and paste and see if everything works fine, and we're just gonna validate if everything works. So let's jump straight into it. So switch one is gonna be having VLAN 10, 20, and 30. So I've written the configs and we're just gonna copy and paste it down. But before we do that, let's just do a show run on those devices and see what we have. So enable show run. So once we put the configs in, everything's gonna look different. And also it's gonna be the same for all this other switches. So let's just go switch one, enable. Okay, so let me just go through what I just did. So right now, this is gonna be the VLAN, for just naming the VLAN for VLAN 10, VLAN 10, 20, and 30. So we gave it a name. Let me close this out. So we give it a name, and the access port is gonna be for the end devices, and the interface range is gonna be for, is also gonna be for the end devices. We just putting it with the interfaces, which is gonna be right on this links right there. So the SVI is gonna be the IP addresses for this switches, like the default gateway for VLAN 10, 20, and 30, because the end devices need a way to be able to reach their default gateway. And also we have also got to put the IP NAT inside, which is going to be for the NAT translation. And in this video, I'm just going to kind of go over what I've done, not really explain it because this is going to take a long time to explain and I don't want to drag this on for too long, but I'm just going to briefly just go over what I've done. So where did I start? Okay, so now we're going to be creating the InterVLAN link to switch 2 and switch 3, which is going to be this links to be able to reach this networks. And from this, we want to be able to reach this network. So, and that's going to be just putting the IP addresses on this for this J108 and this J107. So that's why we have the InterVLAN link to switch 2 and switch 3. So we want to use a no switch port. Basically, if we don't use a no switch port, we're not going to be able to put the IP addresses on the layer 3 switch because it's a router. It does what a router does, but we have to be able to turn the feature on. So that's why we have the no switch port. Because if we try to put the no switch port if we don't try to use the no switch port, this is going to give us an error. So we're not going to be able to put the IP address on this interface. So that's why we have the no switch port right there. And we do the same for the G107, which is for this link connecting to switch 3. And it's also going to be the same for the other switches too. So OSPF, that's going to be the routing protocol we're using because we don't want to use a static route because it's too much work to do. So what we want to do is just put the network path, the network of the IP addresses, and we want to put the network addresses, summarize, put it into OSPF, and just the route is just gonna do it. It's gonna do the route on its own. It's gonna determine the path the traffic is gonna use to reach other networks by using the OSPF. So IP routing is gonna give us the ability to use the feature for OSPF, and the router ID is just name, the logical name for router, the OSPF1, and the 1 is just the process ID. So this is going to be the network addresses for VLAN 10, 20, and 30 on switch 1. So also the network 10, the 10, the 10, the 10, the 0 slash 252 slash 30. Yeah. which is going to be the wildcard mask right there, 0.0.0.3 or /30. It's all going to be in area 0, which is going to be for this, all this, which is going to be in area 0. So we're using a single area. We're using the area 0 for every single one. And the network 10.0.8 and the .12 is going to be for all the links. This links right there. So you can be able to reach this networks. So, and the other thing for DHCP, why do we want to use the DHCP? We don't want to manually assign, what's it called, IP addresses to the end devices because that's too much work to do. So DHCP is just going to give us the ability to just automatically pick the IP addresses. So that's why I've gone with the choice of using the DHCP. So we want to exclude some addresses. So that's why I have this command IP DHCP excluded address. So in every single VLAN, I want to exclude at least 10 for maybe management purposes for if you want to use those IPs. So you exclude those addresses, which is with this commands, and you want to create the name for the pool, the DHCP pool, so you could be able to know, okay, this is the VLAN we working on. And you want to put the network command and segregate it, to be able to define where you're going to be getting the IP from. So you want to point the default router on the switch 1, so the PCs know where to reach. You don't want to get the IP from. So that's why we have the default router. And the DNS server is also, okay, this is our DNS server. We want to be able to ping it. So that's why I also have the DNS server on there. So we do the same for VLAN 20 and 30, and also going to be the same for switch 2 and switch 3. And I'm just going to copy and paste, and we'll see how it goes. So right now we could do, where did we stop? Yeah, I've already put this on there, so that's fine. So in switch 2, we just want to do the same. Switch 2, copy. Okay, and then one other thing I want to show y'all is a show IP route enable. Show IP route. So right now we don't have any routes, but once I put the config, we're gonna see all these networks being linked to each other with OSPF. So let's just get on there. Okay, that should do it. So let's go back and do show IP route. Okay, we can't see the OSPF. Okay, there we go. It took a while to come up. So the OSPF, basically OSPF is gonna be in a down state. And when it's done, it's gonna be in a full state. That's why we have to load into full. And this is gonna be the neighbors, the router ID we made. The router ID, the name for the router ID I was talking about before. That's why we have the neighbor. So that's gonna be for 1.1.1.1. It is gonna be 1.1.1.2.2.2.2, and switch 3 is gonna be 3.3.3.3. Okay, so do show IP route. There we go. So now we have the OSPF routes being summarized. And so 192.168.10.0 is going to be the administrative distance for OSPF. And this is going to be the metric. So right now, 192.168.10.0, which is on this VLAN right there, we're able to reach it via 10.10.1. So it's going to be coming out of here to switch 2. That's kind of why we have it. That's kind of the meaning for this right there. So let's move on to switch 3 and do the same. Copy. And maybe do a show run. Yeah, so we have nothing on this. So once we paste it, we're gonna see the configs. Okay, so don't worry about this. I just made a comment, so it's not even gonna affect it because it's not even gonna count. It's only gonna catch what's needed. So the OSPF state has been moved from down to full. So that's what I was talking about. So now we on switch 3, and the switch 3's router ID is gonna be 3.3.3.3. 3.3.3.3, yes. So this is gonna be the neighbor, the 1.1.1 and 2.2.2. That's why we have this process ID of 1, and the neighbor is gonna be 1.1.1 on G103. Where is it? Right there. And the OSPF moved to the full state because okay, it's being validated that we have a neighbor. That's why it's in a full state. So we can also do a do show run. Okay, I was I was messing up, sorry. Okay, there we go. So now we have the configs, and let's upon the NAT router. So let me try to explain what I'm doing. So in the real world, I wouldn't need to put this router right there. But on Packet Tracer, I can do IP NAT outside. So I'm just gonna use a router just in place for that. So now we want to add this IP address to this interface G001, which is going to be for this one. And it's going to be IP NAT inside. So on the NAT, basically what you want to do on when you're doing that address translation, you want to have IP NAT inside and IP NAT outside. So this is going to be the inside interface. This is going to be the inside and this is going to be the outside. Okay, so let's go ahead. What else am I missing? Okay, there we go. And also we want to do OSPF on this because we want to be able to reach the networks we've created inside for the 192.168/16. So that's we're gonna be using the /16 because we want to be able to reach all these networks 40.50 and 10, 20, 30, and 60. So we want to be able to reach that, and that's going to be using the /16 because the IP addresses is going to be a /24. So using the /16 OSPF is going to give us the ability to reach the networks. So let's just copy it. And also, when you do a NAT, you also want to include the access to permit the one again. I'm using the /16 on there too. And you want to apply the which is going to be IP NAT inside, which is going to be for everything inside. We want it to be translated outside this interface. That's why I said IP NAT inside and IP NAT outside. So every single address we have for this that matches this 192.168 is going to be translated outside the interface J00. And with the overload, that means we could be able to port address translation. If we don't put the overload, we're gonna run out of IP because we're only using one IP to do a NAT translation. Because a public IP, it costs money. So you don't want to buy 1,000 IPs that cost a lot of money. But private IPs, you can do anything you want with it. So we only have a single public IP. We have two, but we have one. So we want to use just a single IP to translate every single inside IPs we have to the internet. And I'm gonna show you all the process of that too very soon. So let's just copy this, put it on the NAT router. Okay. There we go. And that should be good. Okay. And the ISP. So basically I'm just gonna be using the ISP router to simulate a real world modem, like a router you get from what's it called? Maybe Spectrum or uh whatever service you're using, ISP service you're using. So we're just gonna use this to simulate a real world IP. So this is gonna be a public IP address. We're just simulating it. Enable conft, and that's gonna be for this interface right there. So we want to be able to communicate with this network. So let's put the config in there. Now the interface is up and up. And also if you want to see the IP addresses you've made, you could do a show IP interface brief. So there we have it. We have the IP address we have on this router. You can also do the same for this. You're gonna see every single thing. Let's just do that right now. Show IP interface brief. So there we have it. We have the 10.10.1, which we figured on this link, the InterVLAN link to switch to, and we have the 10.10.10.13. Where where is that at? Which is going to be to the NAT router right there. And the status is up and up. So if this is down, if it's something is not working and you want to check, okay, is the interface up? This is where you're going to see it. If it's not, then you want to do a no shutdown on that interface. But right now, everything looks good. So what we want to do is try to see if we can ping the ISP, ping to the ISP. So also what you want to do on the end devices, you want to make sure every single thing is accepting DHCP. If you don't, it's not going to work. So let's see if we're going to get, okay, now we have the default gateway, which is for VLAN 10. So, and that's the DNS server, and let's check the IP address we have on this. So 10.10.10.12. So you remember how I said you want to exclude some IPs. So let's go back and switch one right there. So we excluding 192.168.10.1 and 10.10. So now the next IP we had available is going to be the 12. That's what we were given on this PC. So we have the 10.10.12. So we were not given any IP in this range, the 10.10.1 till 10. So we're using a 10.10. So let's try to ping the ISP and see if everything works just fine. Ping 209.115.10.2. Come on. There we go. So looks like the first ping is gonna fail most of the times. That's not a big deal. So we can try it again. It's gonna work just fine. So we get a reply and the time to leave. So we can also do that on other routers. Let's try to ping from switch PC3 on VLAN 40, and let's see if that's going to work. Okay, that's good to go. So we also want to try to ping between this VLAN to also make sure everything works just fine. So what do we want to ping? We can do a dual ping. Let's try to ping the VLAN 30. So we ping the default gateway 192.168.30.1. Yes, that's good. So everything should be fine. Let's also try to ping from lab 3, switch 3. Dual ping 192.168. Let's do a 50.1. Success. So there we have it. And I think that should be the end of this lab for now. So thank you guys for watching. And in the next video, I'm gonna try to go in depth into each protocol we have on the routers and to explain fully why everything is happening the way it is. So thank you guys for watching. See you in the next video. And also one more thing we want to do is try to translate the NAT by pinging from this end devices. So ping the public IP and also do it from a different VLAN. So let's do it from one more. Okay, so let's open the NAT router. We should be able to do a NAT translation. Show IP NAT translation. Okay, so remember how I said we're going to be using port address translation. So right now we have the ICMP going to the IP and with the 10, and that 10 is a port number. Because if we didn't use the overload command we had at the back before, it's just going to be using a single IP. So only one single thing is going to be able to go through because we only have a public IP, but using the overload, we're going to be able to use port numbers, which is why we have 10, 11, 12, 151. Just all these numbers right there, it's all port numbers.